Hello, good morning. This is from Dr.B.Vijayakumar, HOD of Physics, SNS College of Engineering. Today I am discuss the topic of Introduction to Elasticity, Stress Strain Diagram and its uses. It's under the Properties of Matter unit. The brainstorming session, basic question will be asked from a student side. Define elasticity. What are the application of elasticity? Do you know the importance of elasticity and what is the use of application of stress strain diagrams? So finishing of this PPT, you get this all the question answers. So the introduction to elasticity. The elasticity as the measure of how much of material deformed in response to applied force, ability of a deformed material body to retain to its original shape and size when the force causing the deformation are removed. Hooke's law states that the strain of the material is proportional to the applied stress within the elastic limit of the material. So the stress is directly proportional to strain. A stress is equal to E into strain. E is a elasticity and it's a constant. Stress strain relationship. The stress strain relationship is a describe the material behavior under applied force. It's a crucial aspect of understanding the material mechanical property. Stress is defined as the force applied per unit area of a material. Strain measures the deformation of the material in response to stress, represented as the change in length divided by the original length. So the elasticity is the property of solid material that it gain its original shape and size after the removal of the applied force. But plasticity is the property of the solid material that it does not gain its original shape and size after removing of applied force. So the Hooke's law is a principle of elasticity. The strain of the material is proportional to the applied stress within elastic limit. The importance of understanding elasticity. Understanding elasticity is crucial for designing and building structure that can withstand load and remain stable. Bridges. The elasticity of a steel and concrete is essential for designing bridges that can safely support traffic loads. Buildings. The elasticity of the material allows them to deform under wind load, preventing catastrophic failures. Vehicles. The elasticity of metal and plastic is essential for designing car parts. Aircraft. The elasticity of aerospace material plays a crucial role in the design of the aircraft components. This is the stress strain diagram. So the stress versus strain we form in each and every material. We get in a certain characteristics of the material to form of this diagram represent. So that we discuss one by one. Elastic region, yield point, plastic region, ultimate tensile strength and fracture point. The initial portion of the diagram where the material deformed elastically, meaning it returned to its original shape. The yield point portion of the diagram behind the yield point. Plastic, the point of the diagram which are the materials are deformed permanently. The ultimate strength, the maximum stress is a material can withstand before it begin to fracture. Fracture point, the point of the diagram where the material break or fracture. This is a color diagram of stress strain, and the two important point from then another is a plastic deformation and fractures. So the plastic deformation, the permanent deformation, the necking is in a localized area during to plastic deformation. The fracture, the material break or separate under the applied stress. So the many application is formed in that stress strain diagrams. This is all the reference I am prepared from this PPT. Thank you very much. We discussed in another one topic in another one video. Thank you.